Okay, so in this class today, I want us to look into static routing, which is the basic routing protocol that we're going to discuss. We're going to discuss the basics of routing protocols, a static routing itself, then default static routing, then floating static routing. So, in static routing, we have three types of routing. Static routing itself, then we have a branch that is called default static routing, then another one is called floating static routing. So as I've said earlier, let's start with the basics of routing protocols. So that is up. Okay, so what's routing? We have to understand that routing is a process that is performed by a layer 3 device in order to deliver packet from one from one point to another by choosing an optimal path from one network to another. So by default, a router only knows about the directly connected networks. So for example, in this topology here, this router only knows about only the directly connected network, this one and this one. This router 2 here doesn't know that router 3 exists. So that's why we have to carry out routing protocols so that all these routers can know that they exist in the same network. So they become neighbors and they can send each other messages. Because if we don't implement routing protocol, this router here will not know that this router 3 is here, or will it know that router 1 is here. So we need to connect them using routing protocol so that they can talk to each other and send messages and allow hosts to communicate. All right. So we have several types of routing protocols. One is called static. So static. Another one is called default. Although these are a sub branch of static. Another one is dynamic. And also default can also fall under dynamic, because default route, it should not fall there. So although default route is a static route, but it can't fall under dynamic. So under dynamic we have IGP and EGP. So IGP stands for Interior Gateway Protocol, while EGP stands for Exterior Gateway Protocol. Under EGP we are going to discuss RIP, which is a distance vector protocol. We are going to understand OSPF and EIGRP. So these are the three that we're going to configure under IGP, because they are the most widely used routing protocol. We're not going to configure this one or this one. And under EGP, we're going to configure BGP, which is very, very important. So as I said earlier, we need to start with static routing. So static routing is just a process in which we have to manually add routes in the routing table. So we see that there's no CPU overhead, consumes bandwidth, adds security, as only admin is allowed to add routing of the network, although it's very tiresome. For example, in this topology here, when we want to configure static routing on this table, we have to add it manually so that this router here knows that this router 3 is here. But for dynamic routing protocol, as the name suggests, this router here will automatically know that router 3 is here. But in the first phase of configuration, we are going to do static, of which we are going to add it manually to make this router 2 aware that router 3 is here. Then the second phase is of configuration, we're going to do dynamic routing protocol. As the name suggests, automatically. This router 2 will automatically identify that router 3 is in the network. Alright. So Default routing is a method where the router is configured to send all traffic towards a single router. It doesn't matter to which network the packet belongs to, it is forwarded out of the router which is configured for default routing. It's generally used with stub routers and a stub router which has one or more routes to all other networks. So for example, for a default route, let's say this router here sorry, this router here was connected to another router which is ISP router, but you know ISP router connects a lot of networks, because ISP is the one that connects a lot of networks, internet service provider. So whenever we want to make this router too aware that there are other networks that are connected to ISP, we implement what is called default static route, and we are going to do them practically so that you understand better. So finally, we discuss a dynamic routing protocol. As the name suggests, it automatically adjusts the routes according to the current state of the routing table. Then the dynamic routing protocol uses protocol to discover network destination and the routes to reach it. RIP and OSPF are the best example of that one. Then it's easy to configure because you just have to specify the routing protocol, and that routing protocol will have to advertise all the networks attached and discover all the routers that are there in the network. Then also it consumes a lot of bandwidth, because you know, the router will have to calculate it does it on its own. It has to discover all the routers that are there in the network. Then it is not secure as static route. So the reason why it's not secure, because it can even identify other malicious routers in the network, the one that has been put there by hackers. But for static route, you have to specify it manually on your own. So dynamic routing protocol has the following feature. Routers should have the same dynamic protocol running in order to exchange routes. So for example, if you want to implement dynamic routing protocol here, then all of these routers should run the same dynamic routing protocol, either RIP or OSPF or EIGRP or even BGP. So they must run that one at the same time if you want them to become neighbors. Then finally, when a router finds a change in the topology, then the router advertises to all its network. So for example, we have connected another network here with the router 6, with the router even 7. So router 7 will advertise to router 3 that I have this network. Then router 3 will let these two routers know that another new member has joined them. So that's the advantage of dynamic routing protocol. You just do it automatically. Whenever you add it, then the router themselves let each other knows that there are other change in topology. Okay. So these are the differences between the static and dynamic routing. So there's a lot of differences here. In static routing, routes are user defined. User defined just means that you enter them manually. But in dynamic routing, you know, routes are updated according to the topology. Yeah. Then static routing does not use complex routing algorithms, but for each of these routing protocols, this one, they have to use algorithms to advertise and discover neighbors. And also static routing provides high and more security. Just like I have said, you only specify the network that you want your router to know. But you know, for a dynamic, it discovers everything and form neighbors so long as that that router matches the dynamic routing configuration. For example, when the one router is running OSPF, another one is running OSPF, then they will form neighbors because they are running the same routing protocol. Yeah, so that's a disadvantage because the security there is minimal. Then another one is static routing is manual, just a repeat of point. This one is automated. Another one is implemented in smaller network. Yeah, static routing is implemented in smaller network because you have to manually add routes. So for example, let's say there are 20 routers, so you have to go to each of the routers and add the networks whenever they change. But for dynamic, it will do it itself. You don't need to disturb yourself. Yeah. Then also in static routing, additional resources are required. Yeah. Yes, in static routing additional resources are not required, but for dynamic routing additional resources are required. Okay, then finally in static routing, failure of link disrupt the routing process, but for dynamic routing, a failure of link does not interrupt the routing process. What does that mean? So for example, let's say there are three routers here, and they are interconnected like this, and you've configured, let's say this is router 1, router 2, and router 3. Yeah. So you've configured router 1 to go through router 2 this way, because you don't want it to follow this one directly. You don't want it to follow this one directly. You want it to go from router 1, router 3, then router 2. You want router 1 to go through, you want router 1 to go to router 2 through router 3. So what you do, you implement a static route to follow this path. But what about when this link is broken? That's what we mean by disadvantage of static routing. The routing will fail. And what if you are implementing a dynamic routing protocol? Dynamic routing protocol will just realize that, oh, the main link has failed, let me use the backup. So that's a disadvantage of static routing and the advantage of dynamic routing. Okay, so to the main point today, static routing. We are going directly to the static routing, and I'll just open my packet tracer. I'll open my packet tracer so that we can configure them. The matter of static routing is quite much easier to configure, although it's very tiresome in big networks because you have to do them repeatedly in every router. But for dynamic routing protocol, whenever they change in topology, the routing protocol does the work on itself. You don't need to bother with it. Okay, so just a minute. All right. So I'll draw a simple topology. I'll choose around 4 routers. 1, 2, 3, 4. And switches, 4 of them. And 4 computers.
Is that your daughter?
Sorry?
There's some background sound.
I can't hear you.
I'm saying, is that your daughter playing like a TV? Because there is some noise back.
Oh, I don't. Your voice is not clear.
I'm saying there is some noise coming from like your side.
Yeah. Sure, sure. So
It's
let
the
me
TV.
just yeah.
Yeah, it's better now. Yeah.
Yeah. So it's with the baby watching cartoons near me. I had to keep cool. So I'm going to connect them very fast. Okay, so this is the topology that we're going to use to configure all of these parameters, all of these default static routing, static routing, default static routing, and floating static routing. So I'm going to discuss them when I'm configuring them because it's easier to discuss when you do the configuration. All right. So I just make a little bit of comments. For example, the networks comment. Okay, so the networks. Let's assume here is 192.168.1.0/24. Then here is 2. Sorry. That one 2.0. Here is 3.0, 3.0, and finally here is 4.0. And what about between the routers? Let's say between this router and this router, let's make it 10.10.10.0, or even just that one, not problem. Slash which one can I use here? Let me use just 24 now. Then I want to make here 10.10.10.11.0. Then here is 12.0. Then finally here is 13.0. Okay. Alright. So this is a simple topology that we're going to discuss this various thing. First of all, static routing, static, default, static, and floating, static, routing. So these are the mains that we're going to discuss today. Very, very important in every networking field, because in every project that someone will do, they love to implement static routing. Yes. So I'm just going to explain a little bit. In this network, we are going to tell this router that
you say we're gonna be static, defaulting, static, and the floating static. Is the floating the same as dynamic?
no. These are, how can I say this, types of static routing.
Oh,
Yeah.
So
There's a
we just started with static.
Yes,
We have yet started
we have
with default or dynamic.
Yes, that's what I wrote here. We've started with static. We started with static. Yeah. So there's a way of configuring a general static. Then we can go to default static. Then we can go to floating static. So the first static is just a general static. The second static is a default static. And finally we have a floating static. And they're different. All of them are different. Although they follow the same format. But the logic there is what's different.
Okay.
Yeah. So I'm going to explain. This router to here, it only knows when you shall have configured IP address, it only knows this IP address, this network, and this network. It doesn't know this network, this network, this network, this network, and this network. The same applies to this router. This router here only knows this network, this one, and this one. The directly connected network. It doesn't know about this one, and this one. So, for this router to know that this network, and this network is existing in the network, then we must implement static routing here. We must implement routing protocol. And the first phase of routing protocol is a static routing. So we are going to implement static routing on this router to make it aware that there's this network there's this IP address in the network, this network in the topology, and also this network in the entire topology, because it's only aware of this one, the directly connected networks. So what I'm going to do first is to assign IP address to the interfaces. So for example, this one is gig 02. So I go to gig 02 here. The first thing I do, I turn it on and assign IP address 192.168.1.1, and that's the subnet mask.
Where comes what the other one?
Sorry?
I thought it was 192.168.1.0.
That's a network. So IP address start from .1. We discussed about subnetting days ago. So when you do subnetting, IP address starts from .1. This is just a network. Yeah. So that's like a baseline or something. Then for you to assign something, then you have to take the first one, a base of something. Yeah, a base network. We will normally call it a base network. So this is a base network for that particular group. So for any host to take IP address, then they must start from .1. Yeah. So this is .1. So I'll go to this one, and this one assign them IP addresses. So each one can take .2, 192.168.1.2. Yeah. Then default gateway, as I said, default gateway of this LAN here should be IP address of this router, of this interface, yeah, of this one, because it's the directly connected interface of the router. So it is that interface that this LAN here will be used as the door. Default gateway is just like the door. If you want to get out of your house, you have to use the door. So for example, when this computer here want to get out of this router, they have to use this door. So we have to input them here as 192.168.1.1.
Yeah.
So we proceed to this and do the same 192.168.1.3. Yeah, then 192.168.1.1. Then most importantly, always try if they can reach each other and reach the door. The door was 1.1. They can reach the door. So let me try if it can reach the other PC, which was .2. Yes, that's okay. So we proceed and assign IP. No, I'll just assign IP address to the host on the other side. Then I'll go between the routers later. So for example, on this topology here, I'll go here and check which interface is this one. I'll find this gig02. So I go to this router. I come to config. You can do it through the GUI way, or you go through the CLI the way you normally do it. So for example,
but this way is best.
It's best, but it makes us lazy and forget the commands. yeah. But if you know how to do it to the command line, then it's better. But
yeah, we can do both ways.
Yes. So we just say interface gig 0/2, then IP address to be 192.168.2, then .1, because the first one should be taken by the door. Yes, then the subnet mask to be 255.255.255.0. Then you say no shutdown, exit, and you do right. So if you come here also to this host, you just click on any host. You come to config. You come to desktop, IP configuration, 192.168.2.2 now. Then that's the subnet mask, 192.168.2.1, the door. Don't forget. Yeah. Then you come to this one. That's one. Yes, then you try if they can reach the door and reach each other. Ping, which is the default gateway. I'm just representing as the door so that you can understand better, but the name is default gateway. So that's the default gateway. They can reach the default gateway. Then I go to router 3 and assign forward something. First of all, identify the interface, gig02. You come to config, then you click on gig02, and you, for the first thing, turn it on, port status tick on. Then come to IP configuration 192.168.4.1 as the first one, and that's just done. We're just done with that one. You come with this one, IP configuration. You paste and I change this one to 4.2. I copy that. That's okay. Then 4.1. Then I come to PC2. I do the same. 4.3 now. Then ES 4.1. Then you try if it can reach the default gateway and the other PC ping. Yes, it can reach that PC. Now what about the default gateway? Okay. Then you go to this router also. The first thing you do, you check the interface to assign IP address, and you refer to the network. That's gig 02. It was consistent on my side. Turn it on, and then 192.168.3.1. That's okay. Come to this router, this PC, paste, and I change this to 3.2. Copy 3.1. This one also I do the same. Sorry 3.3 now. Let's say if you can reach the other PC. Okay, and what about the default gateway? Okay, that's okay. All right, so I'll proceed to configure IP address between the two routers, this one, this one, this one, this. I mean the four routers. So for example, this is gig 00, and this is gig 01. So gig 00, I'm going to configure 10.10.10.10.13.1. So I go to gig 00, I turn it on first, and I configure 10.10.13.1, and the subnet mask now should be 2555.255.0 because /24 notation.
I get lost for that at that point.
Okay, I wanted to configure IP address between the routers, so I just check we check which interface is connected to which router. You see that this is gig 00, and the network between gig 00 and this router is this one. So I go to click this router and I click gig 00. The first thing, I turn this on, and I assign IP address, because the first IP address should be 10.10.13.1. Yeah, and the subnet mask is /24 notation. So /24 notation is equivalent to this subnet mask. Yeah. So now we proceed to this other interface, which is gig 01. So gig 01 should take 10.10.11.1. Gig 01 should take 10.10.11.1, and that's the subnet mask. It's okay. All right. So we have assigned IP address to all IP address to this PC, to this router here. Let's move to router 2 here. So router 2, this one is gig 00. So gig 00 should be in this network, and as you can remember, the first interface here took 11.1. Now the interface of this one should take 11.2. Do you understand? Yeah. Okay, so we go to config and the gig 00 10.10.11.2, and the subnet mask should be 225.255
and on.
Yeah, sure, I forgot to do that. Yes, that's okay. Then we move to this one, which is gig 01. Gig 01. So gig 01 is in this network, meaning it should take 10.10.1. So I just go to that one, gig 01 10.10.10.1, and subnet mask that one and turn it on. All right. Now let's move to this router here, which is router 3. Then we first check gig 00. We click gig 00 and we identify which network is gig 00 in. This one, because it's connecting router 3 and router 2. This one, gig 00, and this is the network. So it will take 10.10.10.2 because this one took .1. Yeah, this one took .1, 10.10.10.1. So this one should take 10.10.10.2. So I just click and go to gig 00, turn it on, and I come 10.10.10.2, and subnet mask should be 225.255.0, and that's okay. Now I proceed to this other interface, which is gig 01. So gig 01 is in this network 10.10.12.1. Yeah, gig 01. So we just proceed 12.1. Yes, that's then turn it on. Then finally we go to this router. This router here is connecting, this interface here is connecting router 1 to router 0, and the other interface is connecting router 1 to router 3. So let's check this interface. This is a gig 00. So gig 00 should be in this network. And as you can remember, on the other side, we configured 10.10.13.1. So on this side, we should configure 10.10.13.2. So I go to gig 00, I turn it on, then 10.10.13.2. Then subnet mask should just be 225.225.0. So you have to be very careful so that you don't assign interfaces the same IP address. So or we go to this other interface, which is gig. This one is sorry. Yes, gig 01. So gig 01 should be in this network. And as you can remember, we configured this interface 12.1, meaning so this one should take 12.2. Gig 01. 10.10. It was 12.2. Yes. Yeah. So now assigning IP addresses is complete. And now we are going to begin our phase 1 testing, how to test if these PCs can reach each other and if they can reach any other PC that is outside the network. So as I've told you, this router here only knows about 3 networks: this one, and this one, the directly connected networks. It doesn't know about this one, and this one. So I'm going to try to test from this one, from this PC first to the default gateway, which was 2.1. Then another test will be from this PC to 10.10.1, which was this IP address 10.10.1, which IP address of this one. Okay, so I'm going to ping 192.168.2.1. Okay, that's reaching. Then I'm going to try to ping another network, which is 10.10.10.1. 10.10.
So
Yes.
you started like pinging PC6 to from PC6 to which one?
The first thing, I'm just going to test if they can reach. Like I said, this router here only knows about this network, and this network.
Yeah.
So
yeah.
whenever you try to ping from this one to this network, then it should reach, because this door know that this network is there and this network is there. Yeah, but it doesn't know that the other network is here. So I'm going to first ping from this one to the door first. Then from this one to IP address of this one, which is in this network. Then from this one also to IP address of this one, which is in this network. And you will see that they are pinging. Then finally, I'm going to ping from this PC to any other networks that is available that are not connected to this router. They will fail because this router don't know them. Okay. So that one is also pinging 10.10.10.1, which is this network, and it was IP address of this one. Then also I'll go to this IP, this interface, which is gig 00. Gig 00 was 11.2. So I'm just going to ping 11.2. 11.2. So you can see it's reaching 3 networks. With the first one was 10.10.10, 10.10.10.1. Another one is 10.10.10.11. Then another one is the door, which was 192.168.2.1. Okay, so I'm just going to try to ping from this one to even this one. Let's say IP address of that PC is 1.2. It should not reach because the door doesn't know that there's a network that's resemble that 1.2. You can see destination also unreachable. Then I can even go 3.1. Destination host unreachable 4.1. 4.1. Okay, so that's why we have to implement static routing here. That's why you have to implement routing protocol, and we're gonna implement both routing and dynamic both static and dynamic routing protocols. But in this case, let's start with static routing protocol. So let's make this router aware that there is, remember, I pinged this one and they were all failing. I'm going to do them again after we've configured static routing. Let's make this router aware that there is this network here. Okay, so how are we going to do that? We implement static routing, and I want us to start with the router 0. Sorry. So I want to start from router 0. I want to make this router aware that there is this network, and this network. Alright, so let's go to this router and we come to CLI. Just exit. How do you configure a static routing protocol? It's very, very simple. We just write IP route to which network? Let's start with this network. So this network 192.168.2.0. So let me expand that. Then you write the subnet mask of that network, which is 255.255.255.0. Okay, so you specify that you want to route to this network. I want to route to this network. So when this router finds any packet matching this network, how should it forward it? Where should it forward it? Through this interface or through this interface? So it's very, very simple. It's very, very simple. Just a minute. Okay, so you have to make this router aware that whenever it finds any packet matching this destination, it should forward it through each interface. Let's say, for example, it can forward it through this one or through this one. So let's just take this one for example because it's near it. So we just say through gig 0/1. It was it /1 or /2? Yes, 0/1. And we just hit enter. And that's just enough. Although we find a problem, the default route without gateway, if not point-to-point interface, may impact performance because this is point-to-point. Point-to-point means one to the end, one side, then directly connected. So this one is point-to-point. It's just direct connection between the two endpoints. All right. So that's what we call a static routing. This is static routing. And for static routing, we can do it two ways. We can specify the outgoing interface or the next OP IP address. So you just specify that you want to route through this network. After specifying that kind of command, you give where you want to route it through, whether it can be an interface or the IP address of the next router. So for example, we can just say I want to route this network the way I wrote it earlier. Sorry, I want to route that network. So I want to route just a minute. I want to route this network. Where do I want to route it to? We can specify the interface through which it can go out or the IP address of the next interface. So for example, you can specify this interface as gig 021 or IP address of the next router, which is IP address of gig 00 on router 2. So for example, router 2 gig 00 is 1010 11.2. So when we do that, we're not going to see this error here, because that's one of the most efficient way of doing static routing. But you can do either way. You can specify the interface, the outgoing interface, or IP address of the next interface of the router, the next OP interface. For example, in this case, the next OP is this router, and the directly connected interface is this one, gig 00. So you take IP address of gig 00, which is 10.10.11.2. So you just say 10.10.11.2 and you hit enter. You see, now we don't find that error that we found here, because this normally wants you, when you specify an interface, it wants you to use point to point. This router and this router should be directly connected to each other. Yeah. So when you do this, you don't need to use point to point. So it's you can use either way. All right. So we've just let this router know that there is this network in the topology. So even if you try to ping now, they will not communicate, because this router itself doesn't know that this one is in the topology, although this one has known that this network is in the topology. But this router here doesn't know that this network is in the topology, because we have not advertised it here. So let's go here and advertise the static route here. It should be two ways. If you want to implement a routing protocol to one direction, let's say from point A to point B, you implement static routing to point B. Then you have to specify a way back, because you just given them a way forward. When they reach, how will they come back? So let's specify static routing on this router here to reach this network, and try to ping again. Because right now, if I try to ping, let me just try to ping 1.2, you can see destination host unreachable, because this router here has already known that this network is here, but this router here has not known that this network is here. So the dog cannot let you pass to this network, because it doesn't know it. So let's us make the router know that this network is here. We just implement same static routing. Just come to CLI, enable config T, and IP route. Yes, I want to route to this network, which is 192.168.1.0, having subnet mask of 255.255.255.0. Then I want to route it. We can do it to either ways. We can do it two ways. Through each interface, through this one, which is gig 00, gig 0/0. So you see, when we write that one, we get this for error default route without gateway. If not point to point, may impact performance. But in this case, it's point to point, so we have no problem. Or we can do it this way. Just link that an outgoing interface, and you specify the next OP IP address. Next OP IP address should be IP address of this interface, which is gig 01. So you just go there and check gig 01 to be 10.10.11.1. So we write it here, 10.10.11.1, and hit enter and do it. So I'll go back to this PC and try to ping this 1.2 again. So let's just give it time. It should. It should ping. If it doesn't ping, I'm going to remove one of the static routes so that it can ping, because you can see I did two of them. So maybe they might be conflicting. So what I'm going to do, just again. So you can see it's now pinging. I don't know why it was failing. The other one was 1.3. I go here and 1.3. The first attempt it's failing. So you should use actually it's recommended that you use one, either this one or this one, or this one, because you know this is default static routing. It doesn't use any algorithm, so it's trying to compare. I mean, it's just kind of how can I say this? It's negotiating which one to use, through with this one or this one. So we need to use either of these ones so that to make it more efficient. So if I can just go here and delete the first one, I just say no that one, and do right. Then I also go here and I say no to the first one, no to the first static route, and do right. So if we should now ping now, it should go very, very fast because there's only one path. You know, as initially there were two paths, so it kind of dilemma on which path to choose because it doesn't have any algorithm to help it choose. Yeah. So now let me try to ping from this network. So I go to this one, I come to command prompt, then ping 192.168.2.2. So you can see it's going directly because it doesn't have any two conflicting paths to make the decision. Then 2.3. Wow. So it's just like that, very, very simple. So let's finish configuration. We have only paired these two networks, this one and this one. We've not paired this one and this one and this one, all this one and this one and this one. So let's pair this one. I mean, first let's do this one and this one, or this one and this one. All right. So we just come to this router. It's very simple. Configuring static route is very, very simple. All right. So we just go to that router and we specify another static route. Now to which network? Now to, let's start with 3.0, then 255.255.255.0. Then we want to advertise this network. Where should that packet go through? Should it go through the interface, this one, or the next OSPF addresses? Alright, so what do? We just, in this case, in some cases I want to use the outgoing interfaces. In some cases I just want to use the next OSPF address, but you should know that the best solution has always been the next OSPF address, but you can use any of them. So in this case, let me just use gig 00, which is the outgoing interface to this router. Gig 00. You just write gig 0/0. All right. No matching. No. Oh, sorry. I just wrote no and I didn't write it. So I'll just remove the no. Yes. So it's just the way it was. So I've advertised this network here. I've made router 0 know that there is this network in the topology. So you know, router 0 has already known that this network in the topology, but router 1 doesn't know that there's this network in the topology. So we should make all of them know the status of each other so that they can communicate. If you let only one to know the status of each other, they will not communicate because they are not going to pair. Yeah. They're not going to form peers. They're not going to pair or become friends because it's only one guy who knows the status of the other, and the other doesn't know the status of the other guy. So they are not going to pair. So we already initiated the pair parameters. So let's also make this router know that there is this network in the topology. The first thing that I'm going to do, I'm going to try to ping to this 3.2. Ping 3.2, 3.2. It won't communicate because we have not advertised those networks. That's why it's very, very important to let the routers know the status of each other. Don't do it in complete way. In complete way just mean one way. Do it two way. When you send it forward, give it a path to come back. And if I can just ping it again, it won't communicate because although this router knows that there's this router in the network, this network doesn't know that there is this network. Sorry, although this router knows that there's this network in the topology, this router here doesn't know that there's this network in the topology. So let's make this router know that there's this network in the topology and try to ping again. So I come to this router, I come to CLI, enable config and IP route. I want to route this network. I want to route this one. 192.168.1.0. Then the second was 255.255.0. Through which interface? Let me use interface on that side. On this case, gig 00. Through gig 0 shell 0. And I hit enter. So that's a normal warning, no problem at all. So I'm going to try to ping again. Remember the first I pinged twice and nothing happened. Let me do it again. So let's just wait. I just want to let you know that the best way of implementing a static route is you can use both the outgoing interface or the next op IP address. So you can see it's pinging successfully because this router and this router have become peers. They have known the status of each other and now they can allow their how can I say that, their children to meet and communicate. All right, so like I said, now this router here knows the status of this router. This router knows the status of this router, but this router here doesn't know the status of this router, and also this router doesn't know the status of this router, and this one also doesn't know the status of each other. So this is where I'm saying that static routing is very cumbersome, tiresome to configure because you have to do it manually every time. You have to make the router know that there's this one in the network, there's this one in the network. But for dynamic routing protocol, as long as you've advertised those networks that are there, you just leave it there. It will do it on its own and bring a very high performance result. Alright, so I just want to let this router aware that there's this one in the network, and also make this one aware that there's this one in the network. So I'll just go this way. I'm going to use in this case now I'm going to use this one. I'm going to use this format of using outgoing, the next op IP address. So yes, I didn't yes, I removed this one. I removed the outgoing interface and I used this one. Now in this case, now let me use the outgoing interface. Yes, so I want to route to this network from router 2. I want to route this network from router 2. So what do? I just write it there, 3.0, the subnet mask of 255.255.255.0. Where do I want that packet to follow? Whenever this router finds any packet matching this destination. Where do I want that packet to follow? Through this one, through this one. Yes, there are only two paths, through this one or through this one. In this case, we can use this one or this one. And in this case, let me try to use this one, although it will not communicate immediately, because this router and this router has not formed pairs. So when this router finds a packet from this one, it will not forward it. So let me just use this one still. This one, gig 00 through gig 00, and I hit enter and I do right. All right. So let me try to ping from that PC to 3.2 or 3.1. Ping 192.168.3.2 and I hit enter. It will not ping because although this router knows that there's this network in the topology, but this router doesn't know that there's this network in the topology. So let's make them know the status of each other. Let's go to this one and configure static routing for this one. So I'll just go there, and the other network is 2.0. I want to route to 2.0. So where should my packet follow? I want them to follow gig 00 or the next OSPF address. I can use any, this one or this one. So in this case, let me use the next OSPF address. The next OSPF address is IP address of gig 00 on router 0. So gig 00 can see it's 10.10.13.1. Alright, so I just go here and write 10.10.13. Oh, 10.10.13.1 and I hit enter and do right. Alright, so I'll try again to ping from this PC here to 3.2. Remember the first time I did, it failed because the two routers didn't know the status of each other. But now that the two routers have known the status of each other, I'll do it again. So you can see it's going directly. Alright, so all of these routers here, all the three routers doesn't know the status of the router 3 here. This one doesn't know status of this one, this one. Router 3 has been left alone. So let's configure a static routing on router 3. So I'm going to do 3 of them. Enable config tip. Can you understand it? Very simple, right?
Yeah.
So let's make letter 3 know the status of, let's make router 3 know that there's this network, this one and this one, and we'll go to each router to make them also know the status of router 3. So IP route, let's start with the 1.0, 192.168.1.0, 255.255.255.0, and I want in this case I just want to use the next OSPF address or the outgoing interface. So for this network, I want it to go through this router, then to this router, then to this OSPF address. So I'll just use IP address of the next IP address, which is the IP address of this interface, gig 01. So I go to router, that one, router 1, and check gig 01 to be 12.2. So I just go here and write 10.10.12.2 and I hit enter. Then another network, I want this network, which is 2.0. Now 2.0 I just change here 2.0 with the same separate mask to go through. I just want it to go directly. Just want to go directly. So I'll use the IP address of this interface, which is X01. So if I come here and check X01 is 10.10.10.1, and I just replace here to be 10.1, and I hit enter. And now finally I go to this network, which is 3.0. 3.0 also I want it to go directly because it's just near it. I just want it to go directly. So for 3.0 I just want to use the outgoing interface gig01. Outgoing interface to be gig01, gig 0/1. Yes. So do right. So in this topology, router 3 has known the status of all the routers, but these routers do not know the status of router 3, meaning they cannot become friends, they cannot pair. So I'll just try to ping from router 3 to this network ping 192.168.1.2. It won't ping, and I'm going to ping 2.2 and 3.2, and I'll do it again later when we shall have configured static routing on the 3 other routers, so that the 4 routers can become friends, they can pair. Alright, that one doesn't work. 2.2. That one doesn't work. 3.2 now. So we have to make the routers know the status of each other, and you have to know where to route them to the path through which the packets will follow. You can use the outgoing interface or the next op IP address. Yes, so there's nothing happening. So first I'll go to this router and make it aware that there's this network in the topology. So I go to that router and IP route. I want to route to 268.4.0. The server mask of 255.255.255.0 through. I just want to do it directly because they are just close to each other. Let me use the outgoing interface as gig01, I mean gig 0/1, and I hit enter. Good. I do right there. I come to this router and make it aware that there's this network in the topology. So I come here and enable config T. Then I IP route 192.168.4.1. Sorry, 4.0. That's a network. We don't put IP addresses here. We just put network. Then 255.255.
For routing, we use network, not IP addresses.
Yes, for advertising routes we use network, it's not IP address. The base networks. IP address. This IP address. Generally, it's IP address, but now under IP address we learned that there's a network address and host address. So here we use network address. We don't use host address. You understand that? Yeah. So I wanted to go through. Let me say I wanted to go through this router. The router 3. I mean router 1, then to router 3. So I check the IP address of the next outgoing interface, which is gig 00. Gig 00 in that case is 10.10.13.2. So I just say I wanted to go through 10.10.13.2. Alright, do right. Okay. Alright. Finally, let's make this router aware that there's this this network in the topology. I go to this router here, and I just try to retrieve and change this to 4.0. I change this to 4.0. Alright, I change this to 4.0, I change that to 4.0. And where do I want it to go through? I just want to go through directly using this interface gig 01 because they just directly connected. 4.0. I want it to go through gig 01 0/1. Do right. So if I go to this computer again and try to ping all these networks that fail, it should not work. So let me start with the first one. Just give it some time. Just give it some time. You can see it's pinging now. Then I go to 2.2. 2.2. It should ping perfectly. It should ping. Yes, now I go to 3.2. Yes, so everything is working. That was the first routing protocol, static routing protocol. Now let's go to the types of static protocol, which is default static and floating static. So it was very simple to configure static routing protocol. If I just go to this document here and I do this and make you better understand static routing, what to do, just identify. I have to assign IP addresses, to the router's interface and hosts. Then identify interfaces connecting the routers, connecting between the routers. Then implement static routing. So how do you implement static routing? How to implement static routing? Okay, it's very simple, very simple. The first thing we do after identifying the interfaces, we just issue a command command IP route. Then to that network, let's say it's x.x.x.x, having that subnet mask of x.x.x.x. Then through which path we can use outgoing interface, or next op IP, or next op IP. So these are very important commands. This is a command of implementing all the static routing, be it static itself, then the default static, or floating static. That's the command. What matters here is now the logic behind it. So for implementing static route itself, the first one, static route example. Static route example. We could use just a command IP route 192.168.1.0, having a subnet mask 255.255.255.0, then going through each interface gig 0/1, or example. I just say examples, sorry. Yes, example, that's A. Then now B can also, you can use these examples. Yeah, just a minute. We can use these examples, but we can use these examples The first one you can use the outgoing interface, and another one you can use the next op IP address. Which one? Next op IP. On this case, it can be 10.10.10.1. So that's a way of configuring static routing. You can also call it static route in simple terms. So you just have to understand that this is the general command on configuring the tree. But now what differs is here. So let's move to the next. I'll try to minimize them a little bit for 16. Yes, so 16 is just okay. So let's move to number 2, which is default static route. This is now number 2. Default static route or routing, no problem, it's just okay. So for default static route, the name default basically means it should match all of them, all the routes in the routing table. Default static route. Let's say we've received in this network here. Let's say the way that we didn't pair router 2 with router 1, and we don't want to do it. So we can implement default static route here so that it can go to these routers here, because if that router reaches to this router here, we know that, oh, this packet is matching my friend here. Let me forward it to my friend, and the friend will just distribute it to its host here. So we need to implement default static route here, such that when you don't want to actually make this router aware that there is this network, then we have that default static route that matches all the routes in the network. Default static route goes this way. I know it's hard to understand, but it normally goes this way. Any IP address 0000 with any subnet mask should go through this interface, and the same applies down here. So this is where default static routes come here. We just say any IP address 4 zeros with any subnet mask 40 should go through this interface, or any IP address with any subnet mask should go through this next op IP address. It's quite different from this one, because this one we were specific, and in this case we are general. Here we are specific, but here we are general. Yes, there we are general, but in this case we were specific. So I'll go back to our packet tracer and demonstrate so that you understand better. I was saying that, remember, all of these routers have become friends because they have known the status of each other. But now let's assume that we don't want this router 2 to directly know the status of router 3. Then we can implement a default static route here so that any packet matching router 3 should use the default static routing as the method of reaching this network. So I'm just going to do this router and
repeat that again.
all right, right. It's quite challenging, but I'll repeat it again. default static route.
Oh.
Yeah. There was something that's still here though. Okay, so as I said, default routing or default static, it's just a method, it's just a type of static routing. It's a method where a router is configured to forward all packets toward a single router. It doesn't matter to which network of the packet belongs. It's forwarded out, it's forwarded out that router which is configured for default routing. It's generally used with stub router. Stub router is the router that has only one router. So you can see it's just what I was doing, 00000 00000. So I'll go back and explain better. I was saying in this network, in this topology here, not network, but in this topology, all of these routers have known the status of each other, and they have become friends. They have become peers. They have pair, and now they can allow any host that they are connecting to communicate with each other. But now let's assume in this case router 2 was not paired, or they don't share status with router 1, meaning it will not reach router 1 and router 1 on the other side will not reach it. So how do we achieve communication between them? We implement what is called default static route. And mostly default static route are normally implemented on the ISP side, because it's the ISP that connects a lot of networks that you even don't know. So you just specify that command on your router to make that router aware that whenever it receives any request to IP address that is not in the routing table, then it should use default static route as a method of forwarding that request. So in this case, okay, so in this case, like I was saying, I want to delete the information between this router and this router that is making them become friends. So I'm going to delete the first configuration that we did. The first configuration that we did was this one, 3 dot something. This network was 3. You can see this network was 3.0. So I'm going to try to delete this one. I copy it and I paste it. Enable config T, and I paste it there. Remember, this was the static route that we implemented to make this router 2 aware that this network is in the topology. So I'm going to delete it, and the two networks will not be able to communicate. No, that one. Alright, so let me try to go and ping 3.2. Ping 3.2. 3.2. Destination host unreachable, because I have deleted the information that was pairing there. So I want to assume that I didn't know that this router was here. So I just want to input a default. Something default is just like when something is not met, use that one. Default. When you don't receive, when this packet is received and it's not in the routing table, then use the default path. So how am I gonna do default routing? It's very simple. Just say IP route 0.0, any IP address matching any any subnet mask should be routed through. We can now use like we did before, outgoing interface or the next hop IP address, but in this case I wanted to go this way. I wanted to go this way. All right, I want to go gig 0/1 and to hit enter and do that. Now I'll come back to this PC again and try to ping. So let's just wait. I'll tell you. Let's try to wait. Just wait. The same thing. Okay, I'll go back to this data. Just a minute, and I'll change this to gig 00 first before I do something. And I want to do so I'm just going to try to use let me remove the first one, this yes, this one, and I use this one, gig 00, and I go back again and where was it, 02 again, and ping. Now you can see it's now reaching. I think I used the wrong path. Initially. I could have used this one to go to that network, so I used 0.0. So also let's assume router 0 and router 3, although they are peers now, they have formed they are friends now, because router 0 and router 3 have known the status of each other. So I'm just going to delete status of router, status of this network from router 3 and implement default static route here. So I click enable config T. Which network was that one? It was 1.something is somewhere here. Yes, this one. Copy and I paste. Now I'm going to delete it. Alright, I'm going to delete it. So in this case, this network and this network will not be able to communicate because they don't share status of each other. So I'm just going to try to ping 4.2 now. 4.2. They will not be able to communicate because I have deleted status of this network from the router 3 because I want to do default static routing there. Alright, so let's proceed here and implement default static route. You just say IP route to use 192.1 to 168. No. Default static route is 0.0.0.0. 0.0.0.0. That means any IP address with any subnet mask should go through. Let's try to use this one, which is 10.10.10. If it will go 10.10.12.2. Okay, do right. So I go back to this router and try to ping again. Now you see it's communicating. So sometimes you don't need to advertise. Sometimes you don't need to advertise all the routes. You don't need to tell this router that there's this one, and this one in the network. All you have to do is just to specify this command here. This one, default static route. Default static route covers all of them. It covers all of them because it means any IP address with any subnet mask. So it covers all of them. Whenever the destination is not known. Mostly default static routes are used when the destination is not known, is unknown. So if you don't know the destination, you use default static route. For example, we use static route when we wanted to communicate from this network to this one. So it's pretty much easier to implement default static route, of which we are going to do mostly when we're starting our enterprise networking, and we're going to implement them on the ISP routers, because I told you it's only ISP that connects a lot of networks that we don't know. But in this network we just know all the networks, so we can just implement the first one, static routing. When you know all the networks, just implement static routing. But when a router connects to ISP, you know ISP connects a lot of networks. For example, a lot of networks in town. It provides internet services to a lot of companies. So you use default static routes because you don't know the destination. Alright. So finally, we do floating static route. So floating static route is like a backup. So I go here. I go here and I copy. I paste that there. So floating static route can take the four forms. I can just take this one, copy, okay. Now for default static routes, what we do is just this is a backup routes. So whenever this one fails, either if you are implementing default static or just a static route and it fails, we should have a backup, and the backup is called floating static route. And now how is the backup implemented? We just add a value that is between let's say just a minute, administrative distance of there's something I mean with administrative distance, AD of static route, of static routing. Administrative distance of static routing is a value, I think it's 0 or 1. My network's very slow. Can you hear me?
Yeah.
Okay. So there's something we call administrative distance. So you know, static routing uses administrative distance. So to make a backup, you must give a value that is higher than the administrative distance, so that when the first preference fail, which is the first one that you configured with the default administrative distance, then the backup with the highest the backup with a value that is more than this one should be used. So for example, we see that static routes have an administrative distance of 1. So we just go here and say, suppose we are implementing this route, static route in the network, and it fails. Now we have to design another route in the network. There have to be 2. If one fails, another one picks up. So it must be similar to one that we implement. The floating route must be similar to one that we implement, but the only thing that differs is the administrative distance. This one just uses this default administrative distance. But now for static route, which is the backup route, use a value that is between, I can just say use between 10 to 70. For example, just use 50 here. Now here I use something like 60, 30, and 20. So that's the concept of default static route. I'll explain it again. So in this scenario, let's assume that we were just configuring a normal static route. I was just configuring a normal static route, this one. I chose this one. But for a failover and reliability in the network, you must design what is called a backup route. Whenever this one fails, then this one should come up. So what differs from here to here should be the same with this one. So what differs is this value, the administrative distance. This one just uses the default, this one just uses a default administrative distance of 1. Sorry. And that's why it was not written here. One was not written here because it's just default. So now this one should take a value that is between, let's say just 10 to 70, that's okay. So that when this route fails, this one should pick up. Or the other thing that I forgot, just let me delete something here. I was forgetting something here. This one should be the same until somewhere here. Why am I saying that? Because this one was following this interface. So what if this interface fails and it's the same here? Meaning all of this will fail because it's just following one path. So for a good practice, if there was gig 02, we should use that one. For example, let me just close this one and change this now to gig 02, and this one to be 11 dot something. This should not be the same. That one should not be the same at all. 11 dot something, yeah, something like this. So what should be the same here actually is just the network that is being advertised from here to here, here to here. But this one and this one should never be the same. Also this one, because you know when this link fails, now we should use gig 02 as our main link. But now what is disabled is, you know, what disables it is this higher administrative distance, because we normally take with the default administrative distance. So when these two routes are in use, when these two of them are in use, this one is the one that will be operational. This one will be disabled until this one dies. And when this one is when this one has died, this one will pick up. So the same applies to this one and this one. Also for default static route, we can use backups just like this one. So it's very simple, just like this, very simple. Yeah, so I'll go to the packet tracer and configure floating static route. Is a backup, although in most cases it's called floating static route, but just know it's a backup route. So when I go to packet tracer, when I go here, I want to disable this link. Because I just want to see how many this router here is using this link to go through this one and this one, or this one alone. Let me see the routes that I did advertised. Enable, show, start. So here are the static routes that are here. Alright, so 11.11.2 is going through this link here. 11.2 is IP address of this interface, so it's going through this link, which is gig 01. So I just want to kill the gig 01 so that all the traffic should go through this interface. So what I'm going to do, a route to this network is routed through this interface, which is IP address of this interface of the router. So if you want to go to 2.0 from this router, you just go directly. But now I want to kill this link so that I had another backup route to go this way. I want it to go this way. I want to kill it. So what I'm going to do, we just have to copy it. I copy it and config and I paste it. So being that this was the original static route, I want to design another backup route to go this way in case this one fails. I want it to go this way when this one fails. So the first thing that I'm going to do, I'm going to kill this link here. I'm going to delete it. Alright, and I'm going to try to ping 2.2, ping 2.2. It will not communicate because in this router here, we've been told for you to go to 2.2, then you have to forward all that traffic to this IP address. That IP address was IP address of gig 00, which was connecting these two routers. And I have done with the link. I have cleared the link. I have deleted the link, meaning it's hanging. It cannot forward anything. That's why we need to implement backup static route on this router. So like I said, we have to implement it. So how are we going to implement it? We can use the outgoing interface of this one or the next IP address. But in this case, I'm just going to use outgoing interface and add what is called administrative distance. So just use gig 0/0. Sorry. I just say no to this one. It's incomplete. Just add something like 70. Yeah. Sorry, I should delete this no here. I'm forgetting a lot. And I hit enter. Okay, so this is called backup static route or floating static route. Whenever we don't find this one in the routing table, whenever packet doesn't go through this one, through this whenever this interface dies, when there's no link to this IP address, then this one should pick up. So I'm just going to say do show start. So here also do write, then do show start. You can see there are two routes going to same destination of 192.168.2.0, 192.168.2.0. What differs is just this one, the path. One follows the first path, this one is the first path, the other follows the second path. So the one that follows the second path has higher administrative distance so that it stays disabled until this one dies. So I'll try to ping again. Remember the first time I pinged, it failed. Remember I pinged 222.2 and it failed, so I'm going to try to ping again. So just have to give it some time to see if it will reach. Oh, there's a problem. I think there's a problem with this router here. There's a problem with this. There's a loop somewhere, because in this router here we said that for it to go to this network, then it should go this way, to this one, go this way. So I'm just going to change it. I can remember I configured just a minute. Enable config T, do show start. So you can see I configured that if you want to go through 1.0 on this router, if you want to go to 1.0, then you have to use this interface, meaning this router is sending it to this router. A packet that is destined to this router is sent to this router from this router. When this PC ping, in simpler terms, it comes to this router, and this router says that, oh, that packet is destined to this network, and there are two paths. One path is dead and another path is alive. Let me send it to a path that is alive. It sends it this way. Then when this router receives that request, it analyzes the routing table, which is this one, and it says, oh, 1.0 should go through gig 00, which is it's going back again. It's going back again. Then this one will receive it, it will go back again. So it just rotates there like this one. So I just have to change it this way so that it goes through gig 01. So I'm just going to change it this way. I copy it on this router. And first I say no to that one, no. Then I change it to, I paste and change it to gig 01. Now it should work. Do right. So if I go back to this router here and I ping, now let me wait. If it doesn't work, I'll go back to this router and troubleshoot, because I know when it reaches this router, it should be forwarded directly to this router here. So it's still not going through. It's still not going through. Still not going through. So I check on this router where the problem is. Enable config T. So in this router, let's say I do show start to go to 1.0 to go to, oh, this one doesn't have a way of going to 1.0. Oh, whoa. It doesn't have a way to go to 1.0, so I just have to give it a way to go to 1.0. You can see it doesn't have a way to go to 1.0. So let me copy and paste. There's a lot of problems here. 1.0. This is why I'm telling configuring a static routing is very complicated, because you have to do it every time there's a change in topology, and you will have to do it in all the 100 routers in the network. So that for that one I wanted to go through this interface. Let's say this one is gig 00, yes, gig 00, gig 0/0. So if it doesn't work, then maybe I did it wrongly, but now it should work. Sorry, do right. Okay, so if I go back here and hit enter, now it should try to work, because I've tried to troubleshoot everything. Still not reaching. It's still not reaching. I just want to see where the packet is falling, where the packet is failing. It's still not reaching. Using the default static route. Let me check again. This was gig 00, and the default static route, yes, it was gig 00. So what I'll do, I'll try to delete this one first here, but that should not be the case. Before I do that, I want to know where the problem is. I want to trace where the packet is being dropped. Trace that. Okay, this is where the packet is being dropped. Configuring static routes is very complicated, and I normally don't do it in larger networks. We just do it in smaller networks. Okay, so that's where the packet is failing at the default at the door. So it's not going out with the door. The door was 1.1. So what I'm going to do, I'm going to delete this one. So do right. Then I go again. Try to ping again. It should now work. Default static route is not actually working. It's not working in this case. Actually, it's not working here. The problem is this router. Just again, let me try again. Gig 00. If I change that to 10, so the config, let's say no to this, and I paste, and change this to 10, and write this as the IP address of the next op, the next op, which is gig 00 on this side. Gig 00 on that side is 13.2, 10.10.13.2. do right. So let me try to use that again. Okay, the default static, I mean the floating static route is not working actually in this router. And I'm going to try to figure out where the problem might be, and I'll let you know in the next class, because I can see it's quite late here on this side, and I believe
Yeah.
we've covered most of the things that you wanted to do. So also on your side, you can try to look on the floating static route or the backup route, and you should understand a little bit of basics on it. But for the two of these, they are perfectly working, and if you just follow this video correctly and do a little bit of research, I believe you understand a lot of things about them. So
Sure.
I'm just going to compile a simple assignment and send to you later. So as per now,
Okay.
just send the video, and let's meet again during the course of the day, as you say. Yeah. So just design a day and let me know in advance so that I can arrange and do 1 to 2 hours of explaining dynamic routing protocol, because they are very easy to understand. For around 30 minutes, we shall have covered the 3 of them.
Okay.
Alright. So bye, and let's meet again in the next class. Thank you.